Today we shall discuss Unit 2 Numerical Methods. Here we shall discuss the system of equations, how to find the solution of system of equations using numerical methods. So in our previous semester, in the second semester, we have studied how to find the solution of system of equations. So there we have studied the solution of system of equations using matrices. So Gaussian elimination method, Gauss-Jordan elimination method, LU decomposition method, and other simple methods related to rank. So how the system of linear equations can be solved using matrices, the concept of matrices. Now we shall discuss the same thing, the system of linear equations, how we can find the solution of system of linear equations using numerical methods. So same concept we are discussing in different approach. Now we are discussing numerical methods of that. Now here we restrict ourselves to system of three equations in three unknowns. So the general form of that is a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. So this is the system of three equations in three unknowns. So unknowns are x, y and z. d1, d2, d3 are called constant terms, and a1, b1, c1, a2, b2, c2, a3, b3, c3 are called coefficients of system of linear equations. Now we say that this system is diagonally dominant if we follow this condition, if this system follows this condition. So the first condition is, look into these coefficients. I have a1, b1, c1. So a1, b1, c1. Here look at, I have the coefficients a2, b2, c2. I'll write the diagonal coefficient first. b2, a2, c2. Next, a3, b3, c3. See, a1, b2, c3 are the diagonals. So I am writing diagonals first. So c3, a3, b3. Now modulus of a1 is greater than modulus of b1 plus modulus of c1, and modulus of b2 is greater than modulus of a2 plus modulus of c2. Modulus of c3 is greater than modulus of a3 plus modulus of b3. That means if you had these two numbers, irrespective of their signs, whether it is positive or negative, don't worry about it. If you had these two numbers, then that sum is less than this diagonal entry, then sum of these two entries is less than the diagonal b2, and sum of these two is less than sum of a3 and b3 is less than the diagonal c3. If this condition holds, then we say that this system of equation is diagonally dominant. Diagonally dominant. So whatever the methods we are going to discuss here, that method works only for system of linear equations which are diagonally dominant. If they are not diagonally dominant, then this method won't work. So here we will discuss four important methods. First one, Gauss-Jacobi method, and Gauss-Seidel method, relaxation method, and the last one, Rayleigh-Power method. So the last method is about finding largest eigenvalue and corresponding eigenvector, and these three are about finding the solution of system of linear equations. Now let us discuss what do you mean by the method of Gauss-Jacobi or Gauss-Jacobian method. So as usual, we will consider this system of equations. Then first we have to check whether the given system of equations are diagonally dominant or not. If they are not diagonally dominant, then try to rearrange the equations such that the resultant system of equations is diagonally dominant. See, the three equations will be given. So you can write those three equations in any order. So that if they are not diagonally dominant as in the given problem statement, then interchange equations so that you get diagonally dominant equations or diagonally dominant system. So I'll explain the method along with an example. Since we have sort of time, let us explain the method. Solve the system of equations by Jacobi method. The system of equations is 10x plus y plus z equal to 12, 2x plus 10y plus z equal to 13, 2x plus 2y plus 10z equal to 14. So here the first equation. So sum of these two, 1 plus 1, that is less than 10. Here 2 plus 1, 3, that is less than 10. Again 2 plus 2, 4, that is less than 10. So this system of equations is diagonally dominant. So we can apply Gauss-Jacobi method to find the solution of this system of equations. So to apply this method, so from these equations, so first let us take this equation. From this I can write an expression for x as x equal to 1 by 10 times 12 minus y minus z. And from the second equation write an expression for y. So y equal to 1 by 10 times 13 minus 2x minus z. Then from the last equation write an expression for z. So z equal to 1 by 10 times 14 minus 2x minus 2y. So that is the first step. So from the given equations, first you have to confirm whether the given equations are diagonally dominant or not. If that are not diagonally dominant, interchange the equation. So if possible, you can write this equation in the first place, then this in the second place. So interchange the position of equations to get diagonally dominant system of equations. Then from that equations, write an expression for x, y and z. So this is the second step. Next you have to choose initial approximation. To choose initial approximation, obviously we should take initial approximation as 0, 0, 0. That means you have to take x equal to 0, y equal to 0 and z equal to 0. So write here initial approximation x equal to y equal to z equal to 0. If you take x equal to y equal to z equal to 0, then we will get some value for x here. If you take y and z here 0, then you get a particular value for x. That I will call as x1. So y ಮತ್ತು z ವ್ಯಾಲ್ಯೂ ಏನಿದೆ ಅದನ್ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಆ ವ್ಯಾಲ್ಯೂನ ನಾನು x1 ಅಂತ ಕರ್ಕೊಳ್ತೀನಿ. Obviously ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ 1.2. So constant divided by 10. So that will be 1.2. Similarly ಇಲ್ಲಿ x ಮತ್ತು y ಗೆ 0 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ y ನಿಮಗೆ 1.3 ಅಂತ ಸಿಗುತ್ತೆ. Next on 14 by 10 z equal to 1.4. So initial approximation ಯಾವಾಗಲೂ 0, 0, 0 ಅಂತ ತಗೋಬೇಕು. ಅಂದ್ರೆ x equal to 0, y equal to 0, z equal to 0. Initial approximation ಏನು ತಗೊಂಡಿದ್ರೆ ಆ ವ್ಯಾಲ್ಯೂಸ್ ನ ಈ ಈಕ್ವೇಷನ್ಸ್ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ನಿಮಗೆ x, y, z ಬೇರೆ ವ್ಯಾಲ್ಯೂಸ್ ಸಿಗುತ್ತೆ. ಅದನ್ನ x1, y1, z1 ಅಂತ ಕರ್ಕೊಳ್ತೀವಿ. These are called first approximations. Next, substitute these values in this system. So for my reference, I call this as equation 1. ಇವಾಗ ಇಲ್ಲಿ x1 y1 z1 ಈ ವ್ಯಾಲ್ಯೂಸ್ ಬಂದಿದ್ದಲ್ಲ ಇದನ್ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಅವಾಗ ಏನಾಗುತ್ತೆ x2 equal to 1/10 times 12 minus y ಅಂತಂದ್ರೆ 1.3 minus z1 so y1 ಆಗುತ್ತೆ z1 ಆಗುತ್ತೆ 1.3 minus 1.4 ಇದು ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ x2 ವ್ಯಾಲ್ಯೂ 0.93 ಬರುತ್ತೆ ಅದೇ ರೀತಿ y2 ಅಂತಂದ್ರೆ 1/10 times 13 minus 2 into x1 value ಏನಿದೆ 1.2 minus z1 ಅಂದ್ರೆ 1.4 ಸೊ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ 0.92 ಅದೇ ರೀತಿ z2 1/10 times 14 minus 2 into x1 ಅಂತಂದ್ರೆ 1.2 minus 2 into y1 ಅಂದ್ರೆ 1.3 ಸೊ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ 0.9 so I got x2 0.93 y2 0.92 and z2 0.9 these are called second approximations. Next third approximation. For third approximations ಏನ್ ಮಾಡಬೇಕು ಈಗ ಥರ್ಡ್ ಅಪ್ರಾಕ್ಸಿಮೇಷನ್ಸ್ ಬೇಕು ಅಂತಂದ್ರೆ ಈ ವ್ಯಾಲ್ಯೂಸ್ ನ ಮತ್ತೆ ಈಕ್ವೇಷನ್ 1 ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದು ಸೊ ಅವಾಗ x3 equal to 1/10 into 12 minus 0.92 minus 0.9 ಸೊ ಅದನ್ನೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಆಕ್ಚುಲಿ x3 ವ್ಯಾಲ್ಯೂ 1.018 ಬರುತ್ತೆ ನೆಕ್ಸ್ಟ್ y3 1/10 into 13 minus 2 into 0.93 minus 0.9 so let us write it 1/10 into 13 minus 2 into 0.93 minus 0.9 so we'll get y3 1.024 so similarly z3 will get 1.03 so I got x3 y3 z3 that is third approximation similarly you might get fourth approximations fifth approximations and so on if you continue this process you get successive approximations now look at the values of x y z here I got x 1.2 0.93 1.018 the next will be x4 0.9946 y4 0.9934 z4 0.9916 again ಮಾಡ್ತಾ ಹೋದ್ರೆ fifth approximations x5 0.9934 sorry 1.0015 y5 1.0019 z5 1.0024 next x6 0.996 y6 0.995 z6 0.993 so if you continue in this way approximately you get the values x closer to 1 y closer to 1 z closer to 1 so the solution is the required solution of the system is 1 comma 1 comma 1 so that is the solution of the given system of equations for your confirmation you can substitute these values in these three equations and then check whether you get the same so 2 plus 10 12 plus 1 13 so 2 plus 2 4 plus 10 14 so 10 plus 1 plus 1 that is 12 so this value 1 comma 1 comma 1 satisfies these three equations hence that is the required solution so this is the way of solving the solution of system of equations using the method of Gauss-Jacobi. Next we shall discuss Gauss-Seidel method. Gauss-Seidel method is a generalization of Gauss-Jacobi method. So I have to change the process. There is a very small change in the process. As usual, so given system of equations, let us consider same problem to explain the method, Gauss-Seidel method. So consider the given system of equations, then check whether the given system of equations is diagonally dominant or not. If not diagonally dominant, then try to change the position of these equations to make the given system diagonally dominant. Then write expressions for x, y, z from the given set of equations. From the first one, I have to write an expression for x. From the second one, write an expression for y. From the last one, I have to write an expression for z. So this is a common procedure that is common in both Gauss-Jacobi and Gauss-Seidel. Then choose initial approximation. Initial approximation. That is x equal to y equal to z equal to 0. You have to choose x equal to y equal to z equal to 0. So after choosing x equal to y equal to z equal to 0, substitute this value here. Then you will get, substituting in 1, I will get x1 equal to, I have to take y equal to z equal to 0. So both y and z are 0 means you get x1 equal to 12 by 10, that is 1.2. 12 by 10, 1.2. Now, I have second equation, y equal to 1 by 10 into 13 minus 2x minus z. Now, the difference, here the difference between Gauss-Seidel and Gauss-Jacobi method. So, don't substitute x equal to z equal to 0 here. Instead, take z equal to 0 here. So, y1 equal to 1 divided by 10 into 13 minus ಮುಂಚೆ ಏನು ಮಾಡ್ತಾ ಇದ್ವಿ ಎಕ್ಸ್ ವೈ ಝೆಡ್ ಸೇಮ್ ವ್ಯಾಲ್ಯೂಸ್ ತಗೊಂಡು 0 0 ಹಾಕ್ಬಿಡ್ತಾ ಇದ್ವಿ. ಸೊ ಇದು 13 by 10 ಬಂದ್ಬಿಡ್ತಿತ್ತು. ಇಲ್ಲ ಆ ತರ ಮಾಡೋದಿಲ್ಲ. 13 minus 2 into ಇಲ್ಲಿ ಏನು ಬಂದಿದೆ ಪ್ರೀವಿಯಸ್ ವ್ಯಾಲ್ಯೂ ಇಮಿಡಿಯೇಟ್ ನೆಕ್ಸ್ಟ್ ಈಕ್ವೇಷನ್ ಗೆ ಹಾಕಬೇಕು. ಸೊ 2 into 1.2 minus z ಅಂತಂದ್ರೆ 0. ಸೊ ಇವಾಗ y1 ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ, y1 equal to 1 by 10 into 13 minus 2 into 1.2. So simplifying that, you get the value of y1 to be 1.06. So ಮುಂಚೆ ನಮಗೆ Gauss-Jacobi ಮೆಥಡ್ ಮಾಡಿದಾಗ 1.3 ಬಂದಿತ್ತು. ಇವಾಗ y1 ವ್ಯಾಲ್ಯೂ 1.06 ಆಗಿದೆ. ನೆಕ್ಸ್ಟ್ I want to find z1. So z1 equal to 1 by 10 into 14 minus 2 into x value 1.2 minus 2 into y value 1.06. So ಇದನ್ನು ನಿಮಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 0.948. So first approximations are 1.2, 1.06, 0.948. ಮುಂಚೆ Gauss-Jacobi ಮೆಥಡ್ ಅಲ್ಲಿ 1.2, 1.3, 1.4 ಅಂತ ಬಂದಿತ್ತು ಫಸ್ಟ್ ಅಪ್ರಾಕ್ಸಿಮೇಷನ್. ಬಟ್ ಇಲ್ಲಿ ಫಸ್ಟ್ ಅಪ್ರಾಕ್ಸಿಮೇಷನ್ 1.2, 1.06, 0.948 ಬಂದಿದೆ. ಸೊ ಇನ್ ಚೆಕ್, ದಿಸ್ ಇಸ್ ಕಾಮನ್. ಎರಡರಲ್ಲೂ ನಿಮಗೆ 1.2 ಬಂದಿತ್ತು. x1 ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗಿಲ್ಲ. ಬಟ್ y1 ವ್ಯಾಲ್ಯೂ ಮುಂಚೆ 1.3 ಇತ್ತು, ಇವಾಗ 1.06 ಬಂದಿದೆ. ಸೊ ದಿಸ್ ಇಸ್ ಮೋರ್ ಕ್ಲೋಸರ್ ಟು 1. Actual answer 1, ಇದು 1.06, which is more closer to 1 compared to 1.3. And here also, earlier we had 1.4, but now I got 0.948, which is very close to 1, the exact answer of Z. So the method of Gauss-Seidel is more accurate than Gauss-Jacobi. This gives a more accurate answer, or this gives the answer more faster than Gauss-Jacobi. Next, second approximations. So to find the second approximations, So I have x2 equal to 1 by 10, 12 minus y1 value ಏನಿದೆ 1.2 minus z value ಏನಿದೆ 0.948. So ಅಲ್ಲಿ ನಿಮಗೆ x2 value 0.992. Next x3, y2. Look into this equation. 1 by 10 into 13 minus 2x minus z. So 1 by 10 into 13 minus 2 into x ಅಂತಂದ್ರೆ 1.2 minus z value ಎಷ್ಟಿದೆ 0.948. So ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ 1.005. Next z2 1 by 10 into, sorry, I committed a mistake here. So here 2x1, it should not be 1.2, it should be, I have to substitute this value here, so 0.992, that is the mistake. So x value ಏನು ಬರುತ್ತೆ immediate next equation ಅಲ್ಲಿ substitute ಮಾಡಬೇಕು, previous value carry ಮಾಡೋದಿಲ್ಲ. So z2 equal to 14 minus 2 into x1 here x2, so 2 into 0.992 minus 2 into y2 value 1.005. So this will be approximately 1.398. So now this will be the second approximation. If you continue this process, you get x3 0.9595, y3 0.9682, z3 1.0144. So if you continue it for 2 more iterations, you get approximately the value of x to be 1, the value of y to be 1, and the value of z to be 1. So this is the way of finding the solution of diagonally dominant system of equations using the method of Gauss-Jacobi and Gauss-Seidel. So there is one more method, relaxation method. Also that we shall discuss in another video. Now I will discuss Rayleigh's power method to find largest eigenvalue and corresponding eigenvector. So Rayleigh's power method, that is about finding largest eigenvalue and corresponding eigenvector. So Rayleigh's power method discuss ಮಾಡೋಣ, relaxation method ಇನ್ನೊಂದು ವಿಡಿಯೋದಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಸೊ ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಮೆಥಡ್ ಚಿಕ್ಕದು ಅನ್ಸಿದ್ರು ತುಂಬಾ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸೊ ಲೆಟ್ ಅಸ್ ಗೋ ಫಾರ್ ಅನದರ್ ವಿಡಿಯೋ ಫಾರ್ ಇಟ್. Now Rayleigh's power method or simply power method. Here you will be given with the matrix A. Usually you will be given with 3 cross 3 matrix, square matrix of order 3 cross 3. Now you will be asked to find the eigenvalue lambda and corresponding eigenvector x of largest size. So I have to find the given 3 cross 3 real matrix. I have to find the largest eigenvalue and the corresponding eigenvector. So the method to find this is, you have to choose initial approximation for this eigenvector. That initial approximation will denote by x0. Initial approximation na ee denote ಮಾಡ್ತೇವೆ. Initial approximation, it is a column vector, 3 cross 1 column vector. Either you can take 1 0 0 or 0 1 0 transpose or 0 0 1 transpose. Now usually idantu gottide. Sometimes the initial eigenvector will be given in the problem statement only. Alle eigenvector ಕೊಟ್ಟಿರ್ತಾರೆ, initial eigenvector ಕೊಟ್ಟಿಲ್ಲ ಅಂತಂದ್ರೆ ಇದನ್ನ ತಗೊಳ್ಳಿ. Now we need to find the eigenvalue, the largest eigenvalue and the eigenvector corresponding to that. First I had to write the given matrix Ax in the form lambda into x by taking the highest value in this x as a common factor, then call this as lambda 1 into x1, then it will be lambda 2 into x2, then multiply this eigenvector with A, and that matrix, the resultant matrix, should be written in the form lambda 2 into x2, then take the product of Ax2, then write their product in the form lambda 3 into x3, and continue this process until you get two successive eigenvalues the same or two successive eigenvector the same. So I have to repeat this process usually up to some 7 or 8 steps. Then I have to observe the values of lambda that is going to converge for some particular value, or you get the consecutive terms almost equal. So when you get the consecutive terms almost equal, you have to stop the procedure. Let us take an example to understand this, how to apply the method of Rayleigh's power to find the largest eigenvalue and the corresponding eigenvector of a matrix. Now take up this one. Find the largest eigenvalue and the corresponding eigenvector of the matrix capital A equal to capital A equal to 2 0 1 0 2 0 1 0 2. So this is the given eigenvector, and initial approximation is not given. So we have to take initial approximation as x0 equal to 1 0 0 transpose. Either you can take 1 0 0 or 0 1 0 or 0 0 1 transpose. Now multiply these two. A x0 equal to 2 0 1 0 2 0 1 0 2 into 1 0 0. Usually this will be the first row, 2 0 1, first column. Now take this largest number as a common factor. It will be 2 into 1 2 by 2. So 1 0 by 2 0 1 by 2. So 0.5. So this you have to regard as lambda 1, this as x of 1. Next take the product of A with this column vector. A x1 equal to 2 0 1 0 2 0 1 0 2 into 1 0 0.5. So it will be 2 plus 1 3, or it is a 0.5 times. So 2 plus 0.5, that is 2.5 plus 0 plus 0 0, 1 plus 1 2. So here 2.5 is the maximum number. So 2.5 taking outside, you get 1 0 2 divided by 2.5, that is 0.8. So this is lambda 2, this is x1 of 2. Next, A into x of 2 equal to 2 0 1 0 2 0 1 0 2 times 1 0 0.8. So 2.8 0 0.93. So it will be 2.8 0, it is not 0.93, it is 2.6. Now taking 2.8 outside, it will be 1, 0, 0.93. So I got 2, 2.5, 2.8. Next, I'll write here. I had to multiply A with x1 of 3. This is x1 of 3. So A into x1 of 3 I have to consider. Let us see what it will be. A into x of 3. So that is 201, 020, 102 into 1, 0, 0.93. Multiplying this, we get 2.93, 0, 2.86. So taking 2.93 outside, 1, 0, 0.98. So this is lambda 4 into x4. So continuing this, so sixth iteration. So I'll write sixth iteration directly. So this is fourth one. A fifth iteration will be 2.99 into 1, 0, 0.997. So sixth iteration will be 2.99, 2.999, 1, 0, 0.999. So this lambda 6 x lambda 6 x6. Again, if you continue, approximately get this value 3 and this 1, 0, 1. So the largest eigenvalue is 3 and corresponding eigenvector x is 1, 0, 1. So that is the required solution. So this is the way of solving the method problems on a realized power method. So 3 cross 3 order matrix will be given and you will be asked to find the largest eigenvalue and the corresponding eigenvector. You have to approximate, or we have to start with initial approximation for an eigenvector, either 1, 0, 0 or 0, 1, 0 or 0, 0, 1. Then multiply that with the given matrix, you get a column vector. That column vector should be written in the form lambda into x, taking the largest entry in that column as a common factor. Then repeating the process, look into the values of lambda. When you get successive values almost equal, you have to stop the procedure and write an approximate solution. Though I have 2.93, 2.99, 2.999, so you can write approximately the largest eigenvalue is 3 and corresponding eigenvector is 1, 0, 1. So this is the methods that are used to solve system of linear equations and method to find the largest eigenvalue and corresponding eigenvector. So we are left with a realization method that we shall discuss in another video. So study these methods. Already notes has been shared. So collect the notes from the website. Then study all these problems, whatever the problems that we have listed in our notes. Then get ready for examination. All the best.